Okay, so here's a short video of me going through how all the formulas for sections 11.1 and 11.2 are derived. The first thing to make sense of for the first formula is the formula for area of a rectangle. So here's my rectangle. Amazing art by Mr. Moyer. Oh, by the way, I'll probably say this in a couple of them. I hurt my hand, scraped it on some stuff, so I put a band-aid on it so you didn't see the bloody knuckle. Blah. So I apologize for what's that there for? Well, it's keeping my hand from being visual, the scab being visual. So anyway, when you find the area of something, what you're really looking for is how many little squares can you put in there? And if you say like 1 square inch, okay, or inches squared, however you say it, that means 1 square that's an inch by an inch. Okay, that's what we're saying, 1 inch by 1 inch. So when you say how many squares in a rectangle, or you're asking about that. Well, with a rectangle, what you really can do is you can split it up by horizontal and vertical units. Okay, so there are 2 squares on this side by 4 on this side, so that gives us 1, 2, 3, 4, 5, 6, 7, 8. 2 times 4 is 8. So that's why the formula for the area of a rectangle is area equals base times height, because it's base, height, or a lot of times length times width as well. Length, width. Well, for a parallelogram, which a rectangle is a parallelogram, don't want to forget that. For a parallelogram, so well, Mr. Moyer can freehand this. Not too bad. For a parallelogram, what you can actually do is you can take the height of the parallelogram, and what that does is when you draw it down from a corner to the side, it creates this little tiny triangle here I can trace in red. And what I can actually do is take this triangle, slide it right here. And when I do that, that creates then a rectangle where this is the base, here's the height, and what it ends up giving me is the same exact area. So the area of a parallelogram is area equals base times height. That's because it's really a rectangle, but what you've done is you've cut off that triangle here and slid in there to make it become that rectangle. So really it'd be over here, that triangle would have been originally, and we'd see a diagonal through here. And there's our parallelogram, which will really turn into a rectangle. So area of a parallelogram is area equals base times height, because it's really just a rectangle, so we turn it into. Now our next shape then is a triangle. Okay. The next formula for area is a triangle. Okay, now when you look at a triangle, just draw like kind of a random one. Okay. You should hopefully know, because we've already done this before, that it's area equals 1/2 base times height. But how we get that, aside from saying, okay, well here's a rectangle, which is base times height, and we just cut it in half. That's how a lot of books will explain it. Is it's just half of a rectangle. Well, the other way is this. If I take this weird looking triangle here, and I take it and flip and distort it like this, so that this side here is as long as this one and parallel to it, and this side here is as long as this one and parallel to it, hey, look what I get. I get a giant parallelogram. Now what ends up happening is this side's congruent to this side, this side's congruent to this side, this side's congruent to this side. So these two triangles are congruent. So here's triangle 1, here's triangle 2. So triangle 1 plus triangle 2 equals the parallelogram, which is base times height. Well, these guys are both the same size, so it's 2 triangle 1s that equals base times height. Now divided by 2, triangle 1 is 1/2 base times height. That's why the formula of the area of a triangle is 1/2 base times height, because it's just really half. If I doubled it, it would be a parallelogram and just be half of that parallelogram. Okay. Now our next shape, is really from section 11 too. It is the trapezoid. The trapezoid. Okay. Now the definition for trapezoid, or the important part at least, is that you have one pair of parallel sides, one pair not parallel. And the key to the trapezoid is if you draw in the diagonal, you get two triangles. You get triangle A, you get triangle B. Now, this guy here, his base for triangle A is base 1. Triangle B has base 2. But, so they have different bases. But, they actually both have the exact same height. Okay. So the area of the trapezoid is 1/2 base 1 times height, because that's this guy here, plus 1/2 base 2 times height, and that gives us the two triangles. And then through some fancy factoring, you take out the 1/2 and the height, and you get base 1 plus base 2, which is our traditional formula for area of a trapezoid. But really how it works is you're having two separate triangles that have the same height but different bases. So you add the two triangles together, that gives us overall then 1/2 height times base 1 plus base 2. Okay. Our next shape, the rhombus. Now the rhombus is a parallelogram. So that's one of the things that kind of makes it tricky, is that you could use the parallelogram formula for area sometimes, but if it's specifically a rhombus, the key there is twofold. One, the sides are all congruent, like a diamond, which I drew very poorly here. And then when you draw this in, you also get perpendicular diagonals. Okay. And the diagonals also bisect each other. Okay. So what we get is you can think of this either 4 small congruent triangles, or what's easier to think of it as is 2 big congruent triangles. We'll say the one in red, okay, and the one in blue. Okay. Now, with that, the height, okay, let me turn it this way for us. The height for this guy here, the height is actually half of one of the diagonals. I'm going to call it D1 for diagonal 1. This height, same thing, 1/2 D1. But for both of them, their base is the whole diagonal length. Okay, so here's the base, diagonal 2, diagonal 2. For this other one, this one here, the whole diagonal is diagonal 1, but this guy's half of it because it's been cut in half. This guy's half of it because it's been cut in half. So area-wise, the rhombus is triangle 1 plus, I'll call it 1 in triangle, 1 in blue, triangle 1, plus triangle 2. That's the one in red. Well, triangle 1 is 1/2 base, which is D2, times height, which is 1/2 D1. And the red one is the same exact formula. Okay. So then I multiply those together. 1/2 times 1/2 is 1/4. And then D2 times D1, just, I'm going to alphabetize, put it in order. D1, D2. And then the one in red, 1/2 times 1/2 is 1/4 again, and then D1 times D2 is just D1, D2. And then a fourth of something plus a fourth of something, well, 1/4 plus 1/4 is 1/2, because it's 2/4. Let me do this. 2/4, which is 1/2. So hey, in the end this is 1/2 diagonal 1 times diagonal 2. And that's the formula for area of a rhombus, 1/2 D1 times D2. Now the last shape then is the kite. And the kite works the exact same way, because a kite, if I draw it out, is just a rhombus where this is drawn, where one side's longer than the other one basically. So again, height here is 1/2 of diagonal 1, 1/2 diagonal 1, and the base for both of them are D2. So it ends up being the same as a rhombus. For the same reason. Okay, so there are all the formulas for sections 11.1 and 11.2. Yeah, so there you go.